Hello, today I'm going to talk about how to find historical weather data for positions above the surface of the Earth. Why might you need to do this? Well, there's two reasons I personally have needed to do this in the past. The first one has to do with contrails. People often in the conspiracy world think that contrails are these chemtrails, and they say that they're forming at an altitude that's too low for contrails to form. So I used to have to look up the weather data at a certain altitude to see if a contrail could form at that altitude. But what I'm really interested in today is the wind speed and the wind direction at a certain altitude, historically at a certain time, date, location, and altitude. And the reason I'm interested in this, of course, is because of UFOs. Now, a lot of UFO sightings are balloons, and a lot of UFO sightings are suspected to be balloons, or someone says they might be a balloon, or they claim that it is a balloon, or they might claim that it isn't a balloon. And one of the reasons that people say something can't be a balloon is that they think that the wind is blowing in the wrong direction, and they will look up some historical source of wind data, and they will get it wrong, and they will often say that the wind's going in this direction when it's actually going in a different direction. A specific example here is this rubber duck UFO. The rubber duck UFO is possibly a drone, or it's possibly a bunch of balloons that are just like flying over in a certain direction, just being carried by the wind. Now, we did a bit of analysis on this earlier, the rubber duck UFO, and we've got like a whole bunch of locations of where the plane was. The plane that was taking the video, and we tracked down the plane. It's called Irons 12, and these are the positions that we have data for. They're just rough data locations, but it tells us kind of that, here's 1, 2, 3, and it's roughly going in circles, kind of roughly north west. So if it's following a balloon, then we would need the wind speed to be going northwest. It would need to be going, roughly the same way that this plane appears to be going. Very rough data, but this is what we've got. Now, we also have for this plane an altitude, because we have some more detailed data, and we can see where the flight path of the plane and the ground track of the camera, their lines of sight here will intersect around here, and it's probable that where they intersect is where the actual balloon is, if it is in fact a balloon. So it's probably at around this altitude, 2,524 meters, say 2,500 meters above sea level. So what we need to do is try to find the historical wind direction for that particular location. The first thing that people will do is look up a historical weather site, like Weather Underground. Has history from going quite a long way back. You can put in a location, and you can put in the date, and you can get a little graph showing you what the wind speed was. And the wind speed here, we can see, was pretty low at night and early morning, and then it ramped up to around 15, and it's actually going, in the right direction at that time. But that's 9 a.m., and if we look at the time here, it says 9 a.m., but it's actually Zulu time. Now, this is another important thing that people often get wrong, is they don't actually use the correct time. They'll use the wrong time zone. They won't account for daylight savings time, or they'll just use the day. And because the wind speed and direction varies so much throughout the day, that's going to lead you to the wrong result. So here we have 0900Z. Z is for Zulu. Zulu time is Greenwich Mean Time, also known as UTC, and so you need to convert that to local time, or always just use GMT, UTC, or Zulu time. They're all the same thing. So if we convert that to mountain time, which we have here, let's see, is this mountain time? I think this might be my local time, but it's about the same because I'm on Pacific. So it's about 7 or 8 hours earlier than that, so it will be down here. So the surface winds in Tucson, which is near to our site, are very low. They're also going roughly in the right direction. So that kind of works, but then the winds really aren't very fast enough. But the problem, of course, here is we're just looking at surface winds. You don't want to look at surface winds. You want to look at the winds aloft. And you can get a very good idea of how much the winds aloft, the winds at different altitudes, vary from the winds at ground level by using this site, earth.nullschool.net. And this shows the wind. It's basically got these green lines that show you which way the wind is blowing and kind of how fast the wind is blowing. And you can see this is today's weather. It's very windy. And what we want is a spot somewhere around here, somewhere on the border, just 50 miles south of Tucson, which is where the UFO is. And we can get a lot of information here. I've clicked on this location here. And what we can do is we can actually edit the URL to get it exactly the same as the UFO location. So I'm going to go minus 111.45 and 31.56. And you see, you already had that in earlier. And that will just move this little dot here to that correct location. So this is the wind right now. It's 40 kilometers per hour. You can change that to miles per hour, which is a much more friendly unit for us Americans. I am more or less American now. Then, open up this box here. We can, by default, it's showing you the surface winds. And the surface winds, are of most interest to most people. But if you're flying or if you're interested in UFOs, that might be balloons, you want to have the winds at altitude. These numbers here represent air pressure. It decreases as you get higher. So you can pick an air pressure, and it relates roughly to a certain altitude. So if we go to 850, that relates to about 1,450 meters. Go to 700 hectopascals or millibars, that's about 3,000 meters. And we can see the difference between the 3,000 meter winds, it's this big swirl around here, and the surface winds, which are kind of more irregular. Now you'll have to see vastly big differences because we're on a very windy day today. The winds are actually fairly similar in the lower altitudes. So we want to go back in time. Let's go back to the date in question. And we go here, and it was 2019. It was November the 23rd. And we get a few choices for time. Down here, it's local time. We want to switch that to UTC. Remember, that is the Zulu time. And that's at 9 o'clock at night at the moment. So we zip that back to 9 o'clock in the morning UTC, which is really the middle of the night in Arizona. And now we can see we're looking at the surface winds here, and they're just kind of meandering around on that day, 2019, November the 23rd at 9. And let's see what the difference is at different altitudes. So go to 850. Remember, this is 1,450 meters. You can see that before they were going down at a kind of 45 degrees, going towards the southwest, and now they were going west, slightly northwest. And they go to 700. This is just another 1,500 meters higher. The wind is going in completely the opposite direction, which is something that happens. Sometimes you can get a fairly small change in altitude can create a very large difference in the wind direction. Now, the wind direction we actually want here is in between these two. It's in between 850 and 700. So can we kind of take those two values and interpolate and say it's halfway between this direction and that direction? Well, that's kind of nothing. So really, it could be in pretty much in any direction. Let's go a little bit higher still, and we see it's just a very strong wind blowing towards the east from the west. This is another area of confusion, is that often winds are given in terms of the direction they are blowing from, and people think that the direction is the wind, the way it's blowing to. So if someone says a north wind, that isn't a wind blowing towards the north, it's a wind blowing from the north. You can think of it intuitively. A north wind is a cold wind because it's coming from the wind. A southerly wind is a warm wind. So if you think of a wind at the west, it's blowing towards the west, but a wind from the west blows from the west, so a westerly wind comes from the west. Can be confusing. You got to make sure you got it right. Okay, so you can see that the headings on the winds here tell you where it's coming from. If we look here, it says 85 degrees, which is 90 degrees over towards the east, so it's coming from the east, and this can confuse people. So Another thing that people do, which can be a mistake, is use atmospheric soundings. Now, the way this particular site works is that it's using what's called a 0-hour weather forecast. It's taking all the data from all the different sensors we have around the world, all the weather balloon soundings, and all the ground stations, and all the satellite data, and that's all being pumped into a model. There's various different models, computer models, and the model will forecast the weather. Now, the main purpose of forecasting the weather is to predict what it's going to be like a few days in the future. But it also allows you to figure out what the weather will be like between two weather stations. Because it gives you, if you take the 0-hour forecast, which is essentially the forecast for what it is right now with the most up-to-date data, then you can pick a spot in between two weather stations, and you can calculate in a much more exact way than simply averaging the two what the weather is going to be like at that position. But a lot of people will just take a single sounding. They'll take one weather station. Now, what do I mean by a sounding? Well, weather at altitude is mostly derived from weather balloons. And a weather balloon is just a big balloon that is sent up into the sky. And it has a little radio and a little bunch of instruments underneath it, and it measures the wind speed and the temperature and the humidity and some other things at various altitudes as it rises up through the sky and radios it back down to the ground. And they do this twice a day from a number of stations across the United States. And there's various sites that you can use to look up what the actual results are. There's one in Tucson. There's one just about here, a little bit, about 60 miles or so to the north of this site, and that's the closest one to this site. And it looks like this. This is a weather balloon. This is the weather balloon on the roof of the National Weather Service in Tucson, and it's about to be released. This is a radio sonde, which is the instruments and a little radio transceiver, which will send the data back down to the ground. And they just simply let the balloon go, and it rises up into the air, flies off, and this little thing underneath it radios back the data. So you get this nice vertical trace through the air, and you can figure out what the weather is like in that particular location, and then you feed all that data into these computer models, and it figures out what the weather is like in other locations. But if you just take this data, the data from this one balloon, you're just going to get the weather at that one location, which might not be the same as the weather 50, 60 miles south in the UFO location. So what people will do is they will go to a site like this. The University of Wyoming Department of Atmospheric Science has a page where you can pick these weather stations, and you can stick in the date. You can then click on the weather station. So I'm going to click on Tucson down here. And now before I do that, notice this is the continental United States here, and there really aren't very many. What is that? There's probably like about 40 or so weather stations there, and they're very widely spaced. There's only 2 in all of Arizona, and there's only, I think, 3 in all of California. So if you're trying to find the weather for a particular location based on a sounding, it's not going to be that close. Because if you go back to the Earth site and look at just the variation, say within a location like this is one site is blowing one way, and just a bit further over here, very close to the same weather station, is blowing in completely the other direction, and the weather station itself will have a third wind speed. So if you're using the data from a sounding, it may well be completely wrong. It could be 180 degrees away from what you're doing, and a different set of numbers entirely. But going back to this, we can actually look at it. It's pretty interesting. Let's click on Tucson. And Tucson is going to give us this long list of data. Now, it gives it based on the pressure, like we were seeing earlier, that you can pick the different pressures. Now, remember we had, 850, and we had 700. So you can see you've got much higher resolution. You've got a much wider range of different things you can pick from here, which is great if you happen to live just directly underneath. If your UFO was spotted in downtown Tucson, this would be wonderful, but the UFO was spotted 50 miles away. But we can kind of use this to kind of validate what we saw earlier. So 750 is, or 700 was one of the numbers. Now here it looks, we've only got 2 knots, very slow wind speed right here. And the direction is at 255. So this is coming from the west, which is what we actually saw in the Earth site. If you go here, you'll see at 700. We have a very low wind speed right here coming from the west, and that matches what we see here. So if you go to 850, we have a wind speed of 7 knots coming from 90. Now 90 degrees is coming from the east, blowing towards the west, which is more or less what we want. And as we go a little higher, it kind of swings down a bit lower, a bit down towards the southwest. So as we're getting around, it's actually in the altitude we want at 2400, it's more or less going towards the northwest, which is useful information if we take that and apply it to these two things here and think that it moves the same way as it does in Tucson, then that very much implies that now we do have a wind direction of about 10 knots moving towards the northwest from the southeast. So that does actually work for the balloon hypothesis, if the balloon's moving at about 10 knots. But it's, like I said, it's kind of difficult to actually take this sounding and apply it to something that's 40 miles away. Now, we're kind of lucky 50 miles away. We're kind of lucky here in that it's fairly close, so it's more likely to be accurate. But we saw by looking at the map that it doesn't take very much for things to go off. But based on everything we know, based on this sounding and based on looking at the actual chart, the actual map of the wind flow, it seems fairly plausible that the wind was in fact blowing towards the northwest from the southeast, a southeasterly wind. So the bottom line is it's quite difficult to get a wind at a specific altitude, at a specific time, and at a specific location. These soundings that we were looking at earlier, they're at 12 Zulu, which is 3 hours later than the actual sighting, which was at 9 Zulu. So even though this all seems to more or less match, 3 hours earlier it could have been somewhat different. If we move over here, we'd actually move this to 12 Zulu. We can see, it doesn't actually change that much, which is good. So we can use this chart to kind of verify our assumptions about the soundings. But we can't tell for sure. We can't be 100% certain that the wind is in fact going in the right direction. We can say it's certainly possible, and it certainly appears that it's going in that direction. But if someone tells you for sure that there's no way it can be a balloon, or for sure it is moving at wind speed, then they're wrong, because you can't tell for sure the vast majority of the times. I'd give this particular one maybe a 90% probability of it being blowing towards the northwest, being from the southeast, but I wouldn't bet my life on it.